Hey guys, welcome to another geometry lesson. Today we want to continue with the angle rules for parallel lines. And if you remember last lesson we did the F rule, so you guys need to be familiar with that if you want to continue with this lesson. So what we're doing is, firstly we want to talk about the Z rule, which is the same thing as alternate angles are equal. So let's talk about what alternate angles are back in Geogebra. So here is our Geogebra construction from last lesson, where we had two parallel lines. Line 1 and line 2 are parallel, and we had a transversal, which was a straight line going across the two parallel lines. And what we want to do now is construct the alternate angles, there's something that we have to do that is a bit strange if you not sure what we're doing. But basically we're gonna create two new points, another point on line 2 and another point on the transversal, and then we're gonna go to the segment between 2 points, and basically I want to join up point C with point D, as well as point C and point E. And the reason why I do that is because only then I can create an angle going from the line 2 to the transversal. So basically without doing that you won't be able to see this angle. And then of course I'm going to create an angle from line 1 and the transversal, and these two angles are what we call alternate angles. So alternate angles are equal. As you can see, it doesn't matter how I change these points, as long as you have a pair of parallel lines, line 1 and line 2, then the alternate angles will be equal. So what are alternate angles? Basically they are angles on different sides of the transversal. So you can see this angle here is on the left of the transversal, this angle is on the right of the transversal. So alternate angles are on different sides of the transversal, and they are also on different sides of the parallel line. So this angle here, angle A, is below the parallel line, whereas this angle here is above the parallel line. So when this happens, which we also call the Z rule, so they're equal. Alright, so let's do a quick example. Let's say I delete this angle here and I rearrange this somehow, and so let me just copy that to my lesson. So I'm just gonna copy this here, and I'm gonna say that these two lines are parallel. So this means that they are parallel, these two lines, and I'm gonna name this angle here X. This angle here is X, so I'm gonna say the question is find angle X, and the answer is angle X is equal to 46.43 degrees, due to the reason that alternate angles are equal, or you can just say the Z rule. The Z rule. Alright, let's go to the third rule for angles on parallel lines. And the third rule is that co-interior angles sum 180. They're angles contained by the parallel lines but on the same side as the transversal. So if we go to Geogebra, basically I'm just gonna create another angle right here from there to there. Oops, let me see if that will work if I just change the degrees. Nope, doesn't work, so I'll have to do the same thing again, create another point there and there, and find the angle, segment A to G, A to F, and draw the angle from here to here. Yep. So now I have the angles, and you can see that these two angles are on the same side of the transversal. So I'll just drag this out so you can see it better. So these two angles are on the same side of the transversal. Here's the transversal, here are the parallel lines, and these two angles always add up to 180 degrees. Doesn't matter how we rearrange it. They're on the same side of the transversal and they'll add up to 180. So doing this problem, let me just delete this object, and I'm just going to copy this back into our question. So I'm going to say this line is parallel to this line, and we want to find the size of angle X. So find angle X. So X equals 180 minus 106.93, which is equal to 73.07 degrees. Okay, so this sums up our angle rules for angles on parallel lines. See you guys again next time.